Hi everyone, Miss Barber here with the Algebra 2A quiz review for your quiz tomorrow on 7-1 through 7-4. So the first question says an initial investment of $1,500 grows at 8% per year. What function represents the value of the investment after t years? And I helped you out there by giving you the equation you would need. Remember, A stands for the initial, so in this case 1,500 would be your initial. And your rate is 8%. Now remember, you have to convert 8% into a decimal. So you either divide by 100 or move the decimal place 2 to the left. Moving it 2 to the left would be 0.08. So the value as a function of time would be f of t equals a times, or sorry, not a. We know a is 1,500. 1,500 times 1 plus 0.08 raised to the t. So you could leave it as 1.08, 1 plus 0.08, or you could combine it to 1 plus 0.08, so it just depends on the multiple choice how it's written, but either is the correct answer. Number 2, Katie bought $250 of Apple stock in January of 1998. The value of the stock is expected to increase by 9.5% per year. Use a graph to predict the year the value of Katie's stock will reach 2,000. Katie's going to be rich, but not really. So this is, again, your initial is your A, and then your rate is 9.5%. So your function, f of t, is going to be your initial times 1 plus 0.095, because again, your rate, you have to divide by 100 to the t. And we want to know when this equation becomes 2,000. So let's go ahead and graph it in order to solve for t. That's probably the easiest. So again, we want to find out when this function is $2,000. So in your calculators, so we're going to go to our y equals, and it's going to be 250 times 1.095 raised to the x, oops, all right, and then we're gonna graph it, or go to the table. You don't have to graph, you can just go to the table, and we're looking, so at year 0, I invested 250, so that was whatever the question said, and we wanna see when I get to 2,000. So I'm gonna look at my y values and scroll till I get to 2,000. Well, I get to 2,000 in year 23. So I don't get there until t equals 23. Well, 1998 was year 0, so I'm going to add 1998 to my t to find out what year this is. And when I do that, I get 2021. So this year, my stock is going to be worth, or Katie's stock, who's me, is going to be worth 2,000. Number 3, use inverse operations to write the inverse of f of x equals x minus 2 over 3. So remember, you want to replace f of x with y, so it's going to be y equals x minus 2/3, and then you switch your x and y. So it's going to be y equals x, or x equals y minus 2/3. And then solve for y. Well, to solve for y, you just add 2/3. So it's going to be x plus 2/3 equals y. And we want to then rewrite it as an inverse function. So f to the -1 of x equals x plus 2/3. So it's really the opposite of the original equation. Number 4, you're going to do the same. So you can switch x and y, and remember f of x is y, so it's going to be x equals y divided by 3 plus 1. We can subtract 1 from both sides to get y by itself, so then it's going to be x minus 1 equals y divided by 3. And then to undo dividing by 3, you multiply by 3. And remember, you're multiplying both things on the left by 3, so you should have parentheses there. So now it's going to be 3 times x minus 1 in parentheses equals y. And then again, we replace y with f of negative 1. So it's going to be f of negative 1 equals 3 times x minus 1. And you could distribute that x, but you don't have to. Number 5, a clerk needs to price a party dress returned by a customer. The customer paid a total of $250.25. That included a gift wrapping charge of $5 and then a 6% sales tax. What price should the clerk mark on the tag? So this time, $250.25 is my answer. So that's the total cost. So that's my total cost. And then I'm going to equal it to 1 plus my rate, which again you divide by 100 to get 0.06. I don't know what my price is, but I know I have to add $5 to it for the gift wrapping. So this is my equation. 1 plus 0.06 is the same thing as 1.06, so I could rewrite that. So 250.25 equals 1.06 times p plus 5. Easiest is probably just to divide by 1.06. 250.25 divided by 1.06 is 236.08. And then I have to subtract the 5 for the gift wrapping. And 236 minus 5 will just be $231.08. So that's how much the clerk should put on the tag. Number 6, write exponential equation 4 to the third equals 64 in log form. So remember, you keep the base. So it's going to be log base 4, because that was the base of the exponent, but then you switch the other number. So log base 4 of 64 equals 3. So that's how you switch it. So then to go the other way, it's log base 5, so now it's 5. Then you look to the other side, to across the equals, so 5 to the negative 1 equals what you're taking the log of, which is 0.2. So that's how you convert from one way to the other. Number 8, evaluate log base 25 of 0.04 using mental math. So again, I want to change it to exponential. So you're going to set it equal to x and then change it. So it's going to be 25 to the x equals 0.04. Well, think about it. If I put any positive number in for x, so if I put 25 to the first in, it's going to be 25. 25 squared is 625. So putting a positive number up here is not going to get me to a decimal answer. So now, instead of putting positive numbers in, let's try some negative ones. So you can go into your calculator again, and I could try 25 to the negative 1. If I could get my calculator to work. Oh, there we go. So 25 to the negative 1. And when I do that, I get 0.04. So negative 1 works. So because 25 to the negative 1 equals 0.004, or 0.04, x is negative 1. So again, if positive numbers aren't working, then go the opposite direction and do negatives. Number 9, tell whether the function 4 times 3 to the x shows growth or decay, then graph the function. Remember to determine, without even looking at the graph, if something shows growth or decay, you look at your base, which in this case is 3. Because my base is greater than 1, because it's 3, this is a growth function. If b was less than 1 but greater than 0, remember it always has to be greater than 0, then it would be a decay function. And then you can just put this in your calculator. I know that 4 is my y-intercept, so I know it's going to start here at 4. And it's going to be a growth, so it's going to look something like that. Again, you can graph it on your calculator to be slightly more specific. So this is always your y-intercept. For number 10, using -3, -2, 0, 1, and 2 to graph the function f of x equals 3x. Then graph its inverse, describe the domain and the range of the inverse function. So we can put 3 to the x in our calculator and then use the table. So clearing that out, we can do y is 3 to the x. And then again, if you press shift graph, which is table, and they wanted it starting at -3. So we have that whole table there, so you could go ahead and copy that down. So let's go ahead and do that. So it's going to be 0.00, it's going to be hard to write this all, 0.03. Then -2 is 0.1 repeating, so I'm just going to write 0.11. -1 is 0.3 repeating, so I'll just write 0.33. 1 is 3, and 2 is 9. Remember, the domain of exponential is always going to be all real numbers. So you can either write all real numbers, sorry, that says all real numbers, or you'll sometimes just see the R like that. Then the range is going to be y is greater than 0. To do the inverse, you switch the x and y, and your base now becomes the log of the base. So log base 3 of x will be your inverse, and then your y's of your first are going to become the x's of your second. Because your domain of exponential is all real, that will become your range. And because your range was y is greater than 0, your domain is x is going to be greater than 0. So remember, to find inverses, you switch the x and the y. Lastly, this is all from 7.4. So writing as a single log, remember, if it's addition, writing it as a single log becomes multiplication. So it's going to be log base 6 of 30 times 7.2. 30 times 7.2 is going to be 216. So this will be the same thing as log base 6 of 216. It says simplify if possible, so we should check to see, is there an exponent when I raise it to a number, do I get 216? So converting it to exponential will be 6 to the x equals 216. Well, I know 6 squared if I try that, so 6 to the second power, that's 36. 6 to the third power is 216. So your answer, simplified, would just be 3. So for number 12, subtraction becomes division. So it's going to be log base 2 of 16 over 2, which is log base 2 of 8. And again, we should check to see for some value, base 2 to what power could potentially give me 8? Well, 2 squared is 4, and 2 to the third is 8. So log base 2 of 8 simplifies to 3. Number 3 wants me to simplify, so similar to what I just did, set it equal to x. 5 to what power is going to give you 625? Well, 5 squared is 25. 5 to the third is 125. And then we could go 5 to the fourth, and we get 625. So that just means your answer is 4, because 5 to the fourth gives you 625. For this next one, it says evaluate log base 36 of 216. Now, 36, you can try to solve it like we did numbers 11, 12, or 13, or simplify it like that. However, 36 raised, there's not going to be a whole number power that when you raise it will give you 216. So this is where we're going to use the change of base in order to use our calculator. So instead of using base 36, I'm going to use the common log base 10 and divide. So it's going to be the common log of 216 divided by the common log of 36. So then in your calculator, you would do log 16 divided by log 36. So log 216 divided by log 36. And you get 1.5. So what that means is 36 raised to the 1.5 power equals 216. And then lastly, number 15, we have to simplify. So let's use our properties. Because I have subtraction, I'm going to use division. So log base 7 of x to the 5th divided by x squared. Well, x to the 5th divided by x squared is x to the 3rd. So this becomes then log base 7 of x to the 3rd. And then remember, when you have exponents, the exponent can come down in front. So then it's 3 times log base 7 of x. And that would be your final answer. All right, that is it for the quiz review 7.1 to 7.4. I hope you all have a great day. Bye.